There's this invisible chemical world that's going on all around us and even inside of us all the time. It's this world of unseen forces, of opposites reacting that shape, well, everything, from the food we eat to how our own bodies work. So let's dive into this hidden chemistry, you and me.
Let's start with something we all know. Just imagine biting into a lemon. You get that super sharp, tangy, mouth-puckering feeling, right? Okay, hang on to that feeling for a second. Now, think about the total opposite. You're washing your hands. That soap has a really distinct, slick, almost slimy feel to it. I mean, these two things couldn't seem more different, but they're actually two sides of the very same chemical coin. And here you can see what I mean. All these everyday things can be sorted into two totally different families, or as I like to call them, chemical personalities. Over on one side, you've got your acids, like the citric acid in oranges or the stuff in apples, and on the other side, the bases. Things like soap, and even the antacids you might pop for an upset stomach. So let's get to know our first character a little better. Meet the acids. The name itself actually comes from the Latin word acidus, which literally means sour. And that, right there, is our first big clue about what they're all about. So what really makes an acid on a chemical level? Well, it all boils down to this. When you dissolve an acid in water, it lets go of this very specific little particle called a hydronium ion. That's H3O+. This tiny ion is basically the source of all of an acid's power and its unique personality. And here are those personality traits in full. They taste sour, they can be corrosive, which is why you definitely do not go around tasting random things in a lab, and they have this classic party trick. They turn blue litmus paper red. You find them all over the place, from the vinegar in your kitchen to the powerful acid that's right inside your stomach. Okay, now for every hero, there's a villain, or for every acid, there's an equal and opposite force, the base. If acids are the sour character in our story, then bases are definitely their bitter counterpart. And yep, just like acids have their signature particle, so do bases. When a base can dissolve in water, we call that an alkali, by the way, it releases hydroxide ions. That's OH-. This is the chemical secret to what makes a base a base. So, what's their deal? Well, bases taste bitter, and they have that slippery, soapy feeling we were talking about. And in that litmus test, they do the exact opposite of an acid. They turn red litmus paper blue. We find these guys in things like soap, cleaning supplies, and those helpful antacids. So let's put them head to head. You've got two totally opposite profiles here. Sour versus bitter, watery versus slippery. They are perfect chemical opposites, but the real question is, what in the world happens when these two powerful personalities finally meet? And this is where the story gets really good, because it's not just about two opposing forces existing separately. It's about what happens when they interact. It's a chemical balancing act. See, when an acid and a base get together, they do something called neutralization. That hydronium ion from the acid and the hydroxide ion from the base, they basically grab each other and cancel each other out. And what are you left with? Two very stable, very neutral things, a salt and plain old water. So how do we keep track of all this? We use something called the pH scale. The easiest way to think about it is like a scorecard, from 0 to 14. Anything that scores below a 7 is acidic. Anything above a 7 is basic or alkaline. And right smack in the middle, a perfect 7, that's neutral. So let's put some numbers on the board. Your stomach acid, it's incredibly powerful, and it needs to be for digestion. It clocks in way, way down on the acidic end, with a pH of around 2. Then you have pure water. It's not acidic, it's not basic, it's sitting perfectly in the middle. It's our ultimate benchmark for neutral, with a pH of exactly 7. And to round things out, let's take a common household base like baking soda, mixed with water. It lands on the other side of neutral. It's moderately basic, with a pH of about 9. Right about now, you might be thinking, okay, this is kind of cool chemistry, but why should I care? Well, it turns out this balancing act is happening everywhere, and it has a massive impact on our day-to-day lives. Let me show you. That heartburn you get, that's too much stomach acid. You take an antacid, which is a base, to neutralize it. Love sweets? Well, the acid they create can drop the pH in your mouth below 5.5, and that's when tooth decay starts. Ever been stung by a bee? Ouch, that sting is acidic, and putting a mild base like baking soda on it can help soothe the pain. And on a huge scale, when rain gets too acidic, a pH below 5.6, it can damage entire forests and lakes.
This stuff really, really matters.
So you see, acids and bases aren't just words in a textbook. They're key players in a massive chemical game that's happening all the time, dictating taste, our health, even the environment. So I'll leave you with this question. Now that you know the rules, where else do you see this game being played?
Hello guys, I hope you have understood the concepts by that video. Now I'm going to show you what are the most important things from this chapter. So acids, bases and salts is a very important chapter in point of view of your boards. So now I'm going to show you what are the most important things. So the first and foremost thing is that you should know the definition of acids, bases and salts. Okay, and the types of acids, the types of salts and the types of bases. Okay, so now you can see these highlighted lines. So these highlighted lines are very important, so you can just take a screenshot of this or you can just mark it in your textbook, because these are important points and there are high chances of give reasons being asked from these things. So you need to learn everything, especially this box. This could be asked as a question because it was a PYQ. Then we have these things, the effects of acids on skin, the properties of acids, so these are also important. And then we have each reaction, which are from the chemical properties of acids. Okay, and then these reactions are also important. Then we have bases, the definition of bases, types of bases and these things. Okay, so these are all important. Well, you can just go through each, you don't need to remember every reaction, just go through these things. That is a salt solution plus base. So this table you have the heading of this table, so you should just go through this. That's it. Then you have these common properties of bases, and universal indicator part can be ignored completely because it is not of much importance, but importance of pH in everyday life is very important, so make sure you study it properly. And then you have salts. In salts, more than the definition, so the preparation of salts is asked, that is this table. So make sure you prepare this table very well, because it will help you in scoring too much marks in your board exam, and I am sure of it. Okay, so make sure you study this table before your board exams. Okay, then you have this preparation of other laboratory salts, so you can ignore this part because not much questions are asked from this point, but you have to just prepare some particular points, like from iron chloride, if I'm not yes, from iron chloride. So this question can be asked as a give reason because it was asked in around 2023 or some year in the PYQ. Okay, so make sure that you learn these concepts. Okay, and even these boxes also, because notes and boxes are very important parts of the topic. Well, the properties of salts is not in our syllabus, so it can be ignored. So make sure you learn these many topics properly, and I'm sure that you will be able to score out from this chapter. Okay, bye.